Hi everyone, this is my special lecture series of Linux programming under my channel Adept to Teach. Myself, Dr. Ramandeep Kaur. I'll be covering the following contents in my lecture.
In this lecture, we'll be discussing what is a file system and what is its structure, how we see the files, how the information pertaining to all the files are stored.
Hope you find my lecture useful. If you like it, you can subscribe it and share the link with others. Thank you.
So Linux has everything stored as a file system. Whatever work you are doing, be it I am adding a pen drive to my device, it's a file. The system reads it, reads it as a file. If I am even attaching my headphones, it reads it as a device, and device is a file. So everything in Linux is in the form of a file system. So whatever you are storing, whatever you are retrieving, whatever manipulation you are doing, that is a type of file in the form of file that you are doing. So file system means how you are arranging the data and how you are organizing the data, how you manage data, how you update the data, how you retrieve the data. So in Linux, even the processes, like if I have to give some commands, if I'm running some background processes, that are also treated as files. Your images, your executables, your programs, your scripts, everything is treated as your files. Now we see the files at three levels. The first level is your physical storage view, the second is your kernel view, and the third is your user view. Physical storage means the physical organization of the data on your storage devices. Now, whatever directory structure you view on your systems, it is a logical view. It is basically a user view that you see you have a D directory, you go to the D directory, you have a folder there as MCA, then under MCA you have a folder Linux. This structure that you see is basically a user view. But actually, on your secondary storage device, in your blocks of storage, where exactly and how exactly the data is stored is not in a hierarchical manner. It is simply you have different data sets, you have different data, you just put it at different locations and you store the location with you. So next time when you go to D directory and you press on MCA folder, then you press on Linux folder and you try to locate an index file, index.html, .text, then at that point of time, what your system is doing, system will locate a directory with an inode number. I'll just get to what is an inode number. System will try to find a directory because everything in your secondary storage is arranged haphazardly. It is not put as the directory structure just like you see in your logical view. It is not like this. Randomly the bits are placed, the bytes are placed wherever the storage location is available, but the address of that data is retained. So whenever we are storing any type of data, the system understands, okay, this is an index.html file, the data is stored here, you have given it a name, and let's take its address as 001. So this index belongs to another directory that is called Linux. That directory is stored at location 005. So you have another location with you that is 005. Now it will check then another location where Linux folder is where MCA folder is there. Then it will go to the MCA folder. It will identify its location. So every directory, every file is stored as a file only, is stored as a file, and the data is stored haphazardly. So the address of all the data is stored. Now how that address is mapped, that is decided in your kernel view, and how it should be shown to you. It should be visible as a logical view to you, that is a part of your user view. So physical storage says it is only concerned with whatever is the physical arrangement of the data at the back end in your storage devices, be it your pen drive, be it your hard disk. Kernel view says it is not concerned with anything hierarchical. It is basically working with what is the inode that is associated with every file, and it is taking care of that inode structure, how that inode numbering is given, where to store its location, what are the number of links that inode has. So you have to have those many hops so you can actually reach to the original destined file. User view says whatever data is arranged in a hierarchical manner that you see on your screens when you try to access through GUI interface. That is your user view. So we'll take all the views one by one. First is your physical storage view. Now, there are different types of file systems that are available, how you are storing the data on your system. So the file systems are like ext, ext2, ext3, riser file system, jfs, xfs, fat, ntfs. There are different types of file system. We'll take all type of file system in detail. Now every file system has their own set of methods, how they are going to store the data, what is the rule of allocation of files, what should be the maximum size of a particular file, and what associated data has to be made simultaneously for kernel's reference. That means the metadata with respect to a file is also created so kernel can reference that particular file. Whatever are the permissions of the file, that also has to be taken care of while your file system is working. This is a structure of Linux file system. It's a very important structure. Now, how in every type of storage device your files are stored? The first is your hard disk record. That means what number of record are stored. Then are your partitions like D, E, F, C, D, H, whatever are the partitions that are available in your file system that you create in your file system. Now every partition has this many number of blocks that you are storing. The first part in any type of partition that is stored is called a boot block, which stores the information, the minimal information of what operating system you're currently working in and from where you have to pick up the devices and what peripheral devices has to be checked. So information pertaining to that is stored in your boot blocks. Second is your super block. Now, super block stores the entire set of entire architecture of your file system, your permissions of the file, inode numbering, its index, whatever are the free files, free locations, whatever file numbers are free, you can give those numbers, that numbers are available, unique numbers are available, whatever space has been occupied, which space is free, what can be the maximum data size. This super block comprises of the entire details, the entire set of data, and followed by that is the inode list. Inode list means how many files are created, their listing, their entire table, their permissions that are stored in inode list. Next is this actual data that is stored in your system. So whatever are the files, whatever are the directories, the actual data block. This is your entire set of data. Now in every partition you will see some parts we are repeating. Like this part, these three blocks are repeated. So after a while, because there may be a lot of inode lists that are available, there may be a lot number of files, a lot of data that is available, and just going back again and again is not possible. So after every set of data block that is stored, this part is repeated, super blocks, and your inode list is repeated. Again you have a set of data blocks, again after data blocks this set is repeated. So the system does not have to go back and refer. It can divide the chunks and the accessing becomes faster. Now, how inode list looks like? It is basically a type of table storage. Now, in that table, there are three columns. I am starting from the top level, going to the detailed level, how every part is looking. So at the top, you have the hard disk where you have the partitions, and hard disk record keeps an information that how many partitions you have created and what serial numbers have been allocated. That means what size has been allocated. For example, if you have a 100 GB hard disk, then you have allocated 40 GB to partition 1 and you have referenced it as C drive. Then next, let's say 150 GB you have given to partition D and you have called it as your D drive, and rest whatever is applicable, that means I think it's 110 GB that is available, you have called it as E drive. This record that what space you have allocated to which partition and how many number of partitions are there is stored in your hard disk record. Every partition comprises of this detail. Every partition has got inode list, and that inode list in return looks like this. So when we come to the inode list, it stores what is the number of a unique number that is allocated to a particular file. So this is a unique number that has been given to a file. Let's say the number is 2. Now in return, this file comprises whatever the data that belongs to this file with unique number 2. Is that only available in one address space, or it's a big file and stored at several locations? I'll come back to what I mean by it is stored at several locations. So if it is stored at 5 locations, I have to have the pointer of those 5 locations, the address of that 5 locations, where the rest of the files are stored. For example, in your entire RAM, or in your entire storage space, let's say the block size, the partition, not the partition size, I'll say, for example, in one particular class, when you sit for your examinations, now we ensure that only 30 students sit in one class. Where does the rest of the 30 students sit? That is maybe another class. For example, the class for 1 to 30 students, enrollment number 1 to 30 students, the class allocated is room number 301. And for rest of the students, that means 31 to 60, the classroom that is allocated is room number 302. So when you are sitting for an examination and the faculty comes for taking your doubts, the faculty should know what are the two room numbers where the entire MCA 5 batch is sitting. So with that faculty number, two address spaces are available. Room number 301, which is a unique number, nowhere again available in the entire building. Room number 302, again it is a unique number, nowhere else the same number exists. So the faculty is working as a inode table, wherein the first faculty might have some enrollment number. For example, I have an enrollment number 040, the employee ID. So I have stored the address space of two room numbers 301 and 302. So whatever information I have to disseminate to MCA, I have to go to two rooms, because part of MCA is sitting in 301 and part of MCA is sitting in 302. So in my mind, there is a map which tells me MCA is sitting in two room numbers. This is such type of map. So when one file cannot be stored completely at one location because of the restriction of size of the block, where the file is limited to a particular size. So rest of the file, if it is a bigger file, rest part of the file is stored at different locations. The pointers of that locations are stored here in data block reference. That means for accessing this particular file, you have to go to three blocks. Block number 3 has some part of data, block number 7 has some part of data, and block number 9 has some part of data. Together, when I combine block 3, 7, 9, then I get the entire file with me. The next part that is stored in inode list table is of permissions. Like what permissions are given to user, what permissions are given to your owner, and what permissions are given to group. So we discussed three types of permissions: owner, who is the creator of the file; group, if you are a part of the group and sharing with the group; and last, user, who may be a guest who has a temporary access, and what permissions are given to that particular user. So those permission sets are stored in your inode table. This we call it as metadata. So all the permissions and all important information pertaining to this, like whatever are the free number of inodes that are available. Now, when I say free inodes available, that means in your entire class, you have a strength of 60. During counseling, some people got migrated to some other college. So that enrollment number got vacant. That enrollment number is free. That enrollment number is available. Somebody else, if takes admission, that enrollment number can be allocated to that student. That means whatever locations are free, that are also stored. So a lot of information is stored in your permissions data metadata set of inode. We'll get back to what this type of data is. Now again, now I'm breaking down this and how we are referring to this number. Whenever we are storing any inode structure, we are not concerned about the name of the file here. Nowhere in the inode list, we are retaining the name of the file. We are only referring the file with enrollment number or the unique number, the index number that is given to a particular file. So inode, I stands for index number that is given to a particular file. Now, but we need to have names also, because at times we are storing the file in a directory structure, like in D drive, in Linux folder, in MCA folder, you have a file called index.txt. So how to identify? There has to be a referencing between the link that user sees. From user perspective, this link is very important, because you have stored your file at a particular location. So when you go to that particular location, you want that file to be available. So that structure system is also stored. So there is a directory list table that is also stored in the system. This directory list is a part of superblock. Now in this directory system, we are storing inode number along with the file name. This is the kernel. This information is retained by the kernel. So this entire data is at your kernel view. Kernel is taking care of the directory structure where you are storing what and what is linked with what. So entire referencing is taken care of by the kernel view. So kernel has to understand what file number, what inode number is associated with what file name. So when you go to D, you click on MCA, you go inside the folder Linux and you click on the file index.html. Now your kernel understands that when you click on D drive, this particular location he has to move in. The address size is this, he points to that, and that is called D. When you click on MCA, he identifies the name MCA and he tries to find out its inode number. Then he will point you to that particular file. So when you double click on MCA folder, it takes the name of the folder, identifies its file number, and then points you inside that particular file. Then again, when you double click on Linux folder, it again takes the name of the file name first, identifies its inode number. Every directory, every file has a different inode number. So it identifies its inode number and then it locates you to the next pointer that stores the data. So pointer to pointer to pointer, this type of information is redirected. D points to MCA, MCA points to Linux, Linux points to the exact file that is your index.html. Now when you double click on index.txt, it again takes the name of the file, locates its inode number, and now points you to the exact data block reference where the exact data of the file is stored. So it redirects you to that place. Now the entire data of that particular file is shown to your screen. So mapping the file name with the inode number is very important. So it retains that this is, let's say, the block structure, the data blocks that is already available with the system, and 2 contains the information that it has to go to 3, it has to go to 7, and it has to go to 9. These are the 3 different locations the file is stored. This directory structure is also available when your inode list table is created. So whenever we say block is the smallest unit of your entire storage space. So whenever we say what is the size, we call the partition the smallest partition to which your file can be stored. That is called a block. Now we have discussed this part. Now coming to inode, what information? The third category, the third part, I said inode stores a inode number, the data block referencing number, and the data, the actual permissions. Now the permissions, etc. Now what are that metadata that an inode structure stores? That is, it stores who is the owner ID. Again, owner, when a person is added as a user, that person's file is created and that person is given a file name. So that is owner ID. So owner ID of the file, group ID of the file, size of the file, type of the file, access permission allowed on the file, number of links or number of aliases of that file, the time, last time of modification of the file, then last time when it was accessed, that is also stored. There is a difference between modification and access. Access means how many times you click and you open it. Modification means if you at any point of time you update the data in the file, that is called modification. The time the attributes were last changed, how many times the attributes of the file were changed. Attributes means maybe permissions, maybe your if you are transferring the file from one location to any other location, then that can be an attribute. Then pointers to the data block, how many pointers are there? For example, for file number 2 there were 3 pointers, so how many pointers, the count of that pointer is also to be stored here. Now this is how your inode structure looks like, wherein at any point of time your inode stores the information pertaining to your machine, then your user details, size. Now here you can see the direct pointers. Direct pointers means you can directly access the file, or you can have a single indirect pointer. That means the file size is quite big, you cannot store the file in one location, then you have stored the file at multiple locations. At first location you have the pointer number 2, which says the file is partitioned into two parts. One file is stored at location number 4 and second file is stored at location number 8. So this will store the pointers to 4 and 8, and this will be the exact location number 4 and location number 8. So a single indirect pointer means there is one link in between which is storing pointers to other files. Now likewise we can have double link pointers. That means you cannot directly access the file. You have one set, then it is storing the data. See just this, double indirect pointer. You have a file size which is very enormous, which could not be stored in two files. So you have stored the file in, let's say, location number 3, location number 8, location number 9, and let's say location number 15. Now this data, two locations are stored with this file number. Location of this file number, let's say, is 13, and these two locations, these two pointers are stored in this particular file. Let's say the location of this particular file is 17. This is your original file with the location number 2. Now the indirect link says you are directly pointed to location number 2, which stores location of two pointers, location number of 13 and location number of 17. So these are two indirect pointers. One you first you go to the pointer number 13. It is again storing the location of two pointers, pointer number 3 and 4. So when you go to point location number 3, it can get the exact data. Like this is 8. Sorry, this is 8. So at next it can locate the data at pointer number 8. Likewise, in the second case, now it will go to next location, that is location number 17, where two locations are stored, 9 and 15. So now the data can be retrieved from here.
Thanks for watching. If you like the video, you can subscribe and you can press the bell button to get further notifications.